Welcome back to my YouTube channel. This video is dedicated to Sant Gajan Maharaj College of Engineering, Maga, and alumni students of Sant Gajan Maharaj College of Engineering, Maga. Today we will discuss about Laplace transform, some standard formulae related to Laplace transform, and applications of Laplace transform used to solve ordinary differential equations. Let's see Laplace transform. Laplace transform. See, the Laplace transform is a powerful tool used to solve ordinary differential equations or higher order differential equations without finding a complementary function, and after that particular integral. So addition of complementary function and particular integral, you will get general solution, and after getting general solution by using boundary values or initial conditions, we are finding the values of arbitrary constants, and after that we are substituting the arbitrary constants in the general solution. It becomes a very long procedure, it is lengthy. So instead of these solves, just we are using Laplace transform to solve ordinary differential equations or higher order differential equations. Now see the definition of Laplace transform. Let f of t be a function defined for first value of t, then integration form 0 to infinity e raised to minus st f of t into dt, provided this integral exists, is called Laplace transform of the function f of t, See the definition of Laplace transform. F of t be a function defined for first value of t. So f of t is a function defined for all first value of t. Then integration for 0 to infinity e raised to minus st f of t into dt. It is definite integral. So why it is definite integral means we are having a lower and upper limits of the integral. So hence we are telling it is a definite integral. So therefore the definite integral is 0 to infinity e raised to minus st f of t into dt, provided this integral exists. If this integral exists, then it is called Laplace transform of the function f of t. Now the Laplace transform of the function f of t is denoted by L of f of t. So this is the symbol used to represent the Laplace transform, and here L is the Laplace operator. L is nothing but Laplace operator. So used capital D is the differential operator while solving linear differential equations. So likewise they are using capital L, and this capital L is nothing but Laplace operator. So therefore I will write Laplace transform of the function f of t. It is the Laplace transform of the function f of t. So Laplace transform of the function f of t is equal to integration from 0 to infinity e raised to minus st f of t into dt, and this is equal to f of s, or it is phi of s, f of s or phi of s. See, once again I will repeat, Laplace transform of the function f of t is equal to integration from 0 to infinity e raised to minus st f of t into dt is equal to f of s or phi of s. So both are having the same meaning. We are using different notations in different books. They are given different notations. It depends upon the author. Either you have to use Laplace transform of the function f of t is equal to f of s or pi of s, where s is a parameter. S is a parameter. It is either real or complex number. Real or complex number. Right? So see, this is the definition of Laplace transfer, and this is the symbolic representation of Laplace transfer. That is the L of f of t, Laplace transform of the function f of t is equal to integration for 0 to infinity e raised to minus st f of t into dt is equal to f of s or pi of s, and s is the parameter. It is either real or complex number. So these all things you remember. Next I go for some standard formulae related to Laplace transform. So I'll write a standard formulae. Standard formulae. See, the first formula I go. Laplace transform of 1 is 1 by s. So first formula you are having. Laplace transform of 1 is 1 by s. Or you can write, yes, it is first formula. That is a Laplace transform of 1 is 1 by s. Laplace transform of 1 is 1 by s. Or you can write Laplace transform of k is k by s. See, 1 and k are constants. So when you have a k equal to 1, you will get Laplace transform of 1 is 1 by s. Laplace transform of k is k by s. Or yes, I will take some examples on this. Laplace transform of 100. Laplace transform of 100 is 100 by s. So this is the first formula you remember. Laplace transform of 1 is 1 by s, or Laplace transform of k is k by s, or yes, Laplace transform of 100 is 100 by s. So these all are yes formulas. That is first formula related to Laplace transform. Second one, Laplace transform of e raised to at. Laplace transform of e raised to at is equal to 1 divided by s minus a. 1 divided by s minus a. Third one, Laplace transform of e raised to minus at. Laplace transform of e raised to minus at is equal to s 1 divided by s plus a. So proof is not required. Directly remember the formula. Laplace transform of e raised to at is equal to 1 divided by s minus a. Laplace transform of e raised to minus at equal to 1 divided by s plus a. Next formula. Next one is Laplace transform of sin at. So next formula I go for here. Laplace transform of sin at. Laplace transform of sin at is equal to a divided by s square plus a square. See, Laplace transform of sin at is a divided by s square plus a square. Next one, Laplace transform of cos at. Laplace transform of cos at is equal to s divided by s square plus a square. Next, sixth one, Laplace transform of sin hyperbolic at. Hyperbolic function. We are taking hyperbolic function here. Laplace transform of sin hyperbolic at is equal to, it is a divided by s square minus a square. Next, seventh one, Laplace transform of cos hyperbolic at. Laplace transform of cos hyperbolic at is equal to, it is s divided by s square minus a square. So these all formula you remember. Next we are having yet one Laplace transform of t raised to n. Laplace transform of t raised to n is equal to gamma function of n plus 1 divided by s raised to n plus 1. This is very important. It is not square root. So many students are there thinking about it is square root, but it is not square root. It is gamma function of n plus 1. See, Laplace transform of t raised to n is equal to gamma function of n plus 1 divided by s raised to n plus 1. And this gamma function of n plus 1 can be written as n factorial divided by s raised to n plus 1. These are the formulas related to Laplace transform. See, once again I will repeat. Laplace transform of 1 is 1 by s. Laplace transform of constant k is k by s. Laplace transform of 100 is 100 by s. Laplace transform of 1000 is 1000 by s. Next, Laplace transform of e raised to it is 1 by s minus a. Laplace transform of e raised to minus it is 1 by s plus a. Laplace transform of sin it is a divided by square plus a square. See, the difference between Laplace transform of sin at and Laplace transform of sin hyperbolic at is that, so both are having the same numerator, but denominator we are having small change. In a Laplace transform of sin at, denominator is having s square plus a square, and in Laplace transform of sin hyperbolic at is having denominator s square minus a square. So these things you remember. Next we are having Laplace transform of cos it is s divided by square plus a square, and here Laplace transform of cos hyperbolic it is s divided by s square minus a square. So both are having the same numerator but small change in denominator. So in trigonometric functions we are having s square plus a square, but in hyperbolic functions we are having s square minus a square is in denominator. Next we are having Laplace transform of t raised to n. So n is first two integers here. So Laplace transform of t raised to n is equal to gamma function of n plus 1 divided by s raised to n plus 1, and this gamma function of n plus 1 can be written as n factorial divided by s raised to n plus 1. So these all things you remember. Next I go for inverse Laplace transform. I go for inverse Laplace transform. Next concept it is inverse Laplace transform. Inverse Laplace transform. Inverse Laplace transform. You already know the definition of Laplace transform. Laplace transform of the function f of t is equal to, you have integration from 0 to infinity e raised to minus st f of t into dt, and which is equal to s f of s or phi of s. It depends upon you. Now I will write Laplace transform of f of t is equal to f of s. Then f of t is equal to, I will take L in this side. So f of t is equal to, you take L in this side, it becomes inverse Laplace transform of f of s. Inverse Laplace transform of f of s. So this L inverse is called inverse Laplace operator. L inverse is called inverse Laplace operator. So therefore f of t, this function f of t is called inverse Laplace transform. Inverse Laplace transform. Inverse Laplace transform. Inverse Laplace transform of f of s. See, at the beginning I am using the definition of Laplace transform. We are having Laplace transform of the function f of t is equal to f of s. So f of t equal to, you are getting L inverse of f of s. This L inverse is called inverse Laplace operator, or we are telling f of t is called inverse Laplace transform of the function f of s. So these all things you remember. Now after this we are having some formula related to inverse Laplace transform. Important formulae related to inverse Laplace transform. See, that is first one. Laplace transform of 1 by s is equal to 1. See, inverse Laplace transform of 1 by s is equal to 1. You know, Laplace transform of 1 is 1 by s. Laplace transform of constant 1 is 1 by s. Inverse Laplace transform of 1 by s equal to 1. Second one, inverse Laplace transform of 1 divided by s minus a is equal to s e raised to at. See, you already studied Laplace transform of e raised to at is equal to 1 divided by s minus a. Laplace transform of e raised to at is equal to 1 divided by s minus a. Inverse Laplace transform of 1 divided by s minus a equal to e raised to at. Next, third one, inverse Laplace transform of 1 divided by s plus a. Inverse Laplace transform of 1 divided by s plus a is equal to e raised to minus at. E raised to minus at. So we are studying about inverse Laplace transform here. So once again I repeat, so important formula which is related to inverse Laplace transform. So Laplace transform of 1 is 1 by s. Inverse Laplace transform of 1 by s is 1. Laplace transform of e raised to at is 1 divided by s minus a. Inverse Laplace transform of 1 divided by s minus a is e raised to at. Next, Laplace transform of e raised to minus at is 1 divided by s plus a. So likewise, inverse Laplace transform of 1 divided by s plus a is e raised to minus at. Next one, fourth one, we are having inverse Laplace transform of 1 divided by s square plus a square is equal to 1 by a into sin 80. So this is the very important formula. Very important formula, you remember. Inverse Laplace transform of 1 divided by s square plus a square is equal to 1 by a into sin 80. Next formula, I will go. I go for next formula. Inverse Laplace transform of s divided by s square plus a square. S divided by s square plus a square is equal to cos 80. Is equal to cos 80. Inverse Laplace transform of 1 divided by s square minus a square. See, inverse Laplace transform of 1 divided by s square minus a square is equal to 1 by a into sin hyperbolic 80. Sin hyperbolic 80. Important formula, remember. Next, inverse Laplace transform of s divided by s square minus a square is equal to cos hyperbolic 80. So h is a hyperbolic function here. Cos hyperbolic 80. Next one, inverse Laplace transform of 1 divided by s raised to n plus 1 is equal to n factorial divided by s raised to n factorial divided by s raised to n. So this is the very important formula, you remember. See, yes, it is t raised to n. I am sorry. Inverse Laplace transform of 1 divided by s raised to n plus 1 is equal to s raised to n plus 1 is equal to t raised to n divided by n factorial. A small change and you remember it. So inverse Laplace transform of 1 divided by s raised to n plus 1 equal to t raised to n divided by s n factorial. So these all formulas you remember. So these formulas are used to solve ordinary differential equations, right? So now I go for applications of Laplace transform. So Laplace transform is used to solve the ordinary differential equations, right? So let's see the example, very important example. solve using Laplace transform, solve using Laplace transform method y of 0 is equal to minus 2, y of 0 is equal to minus 2, comma y dash of 0 is equal to 8, y dash of 0 is equal to 8, y double dash plus 4y dash plus 4y is equal to 6 into e raised to minus t. 6 into e raised to minus t. So see, we are having a second order non-homogeneous differential equation test. So repeat the problem once again. Solve using Laplace transform method. Y of 0 equal to minus 2, y dash of 0 equal to 8, y double dash plus 4y dash plus 4y equal to 6 into e raised to minus t. So these are nothing but initial conditions, boundary conditions we are telling these two. And this is a non-homogeneous differential equation. We are solving these non-homogeneous differential equations by using Laplace transform. So before going to this, I will tell some more formulas which you use to find the Laplace transform of derivatives of the functions. So see, Laplace transform of derivatives of the functions. So this concept is very important. I will write side here. So these whole formulas we are using in this problem. So that's why. So these formulas are very important. That is Laplace transform of derivatives of functions. So now see, Laplace transform of derivatives of function. Laplace transform of derivatives of functions. Laplace transform of derivatives of functions. Laplace transform of derivatives of function. See, Laplace transform of y dash. Laplace transform of y dash it is. So Laplace transform of y dash means what? It is Laplace transform of first order derivative. First order S differential equation, that is dy by dt. When how? Laplace transform of dy by dt. At that time, we are writing this as S into y bar minus y of 0. Very important. See, Laplace transform of y dash is equal to S into y bar minus y0. Then what is the y bar? Y bar is a Laplace transform of the function y. Remember. See, first one we are having Laplace transform of y dash. So Laplace transform of y dash is equal to Laplace transform of dy by dt is equal to S into y bar minus y of 0. And here y bar is equal to L of y. Y bar is nothing but L of y. You remember. Next one, we are having a second formula. So second one, it is the first one and this one is second one. Laplace transform of second order derivative y double dash. So Laplace transform of y double dash means it is Laplace transform of d square y divided by dt square. D square y by dt square is equal to S square y bar minus S into y of 0 minus we are having y dash of 0. So this is the second formula, you remember. Next, the third one, Laplace transform of third order derivative ago, y triple dash. So this is equal to Laplace transform of d cube y divided by dt cube. d cube y divided by dt cube is equal to S cube y bar minus S square y0 minus S into y dash of 0 minus y double dash of 0 minus y double dash of 0, and we can continue. Laplace transform of 4th order derivative, 5th order derivative, and so on. So these three formulas are very important because these formulas we are using in this problem. So see, I'll repeat once again. Laplace transform of derivatives of functions. The first one we are having Laplace transform of y dash. So Laplace transform of y dash means it is Laplace transform of first order derivative. dy by dt is equal to s into y bar minus y of 0. And here y bar is equal to Laplace transform of the function y. So y is the function, its value is f of t. So therefore you remember y bar is equal to L of y. Next, second formula, Laplace transform of second order derivative. Laplace transform of second order derivative, that is L y double dash is equal to Laplace transform of d square y by dt square is equal to s square y bar minus s y 0 minus y dash of 0. And we are having third formula. So third formula is Laplace transform of y triple dash. Laplace transform of y triple dash means it is Laplace transform of third order derivative. So Laplace transform of third order derivative is equal to Laplace transform of d cube y divided by dt cube is equal to s cube y bar minus s square y 0 minus s into y dash 0 minus y double dash 0. So these formulas are very important because we are using these formulas in this problem. So remember all of you. Now, yes, I go for the solutions of the given problem. I will find the solutions of the given problem. Let's see. I will write solution. Given, I will write. See, given we are having y double dash plus 4y dash plus 4y is equal to 6 into e raised to minus t. 6 into e raised to minus t. It is the given equation. I call this is equation number 1. This is given equation. See, along with this given equations, they are given boundary conditions. They are given boundary values, that is initial values. So see, we are having initial values are y of 0 is equal to minus 2 and y dash 0 is equal to 8. So these are boundary conditions. These are initial values, right? So now see, it is second order differential equation. It is a second order differential equations because we are having y double dash and it is non-homogeneous differential equation because we are having 6 into e raised to minus 80 on RHS side. So that's why we are telling it as a non-homogeneous linear differential equation. So now I will take a Laplace transform to equation number 1. So I will write taking Laplace transform to the above equation 1 on both sides we get. So I written one sentence here, taking Laplace transform to the above equation 1 on both sides we get. So therefore we get Laplace transform y double dash plus 4y dash plus 4y is equal to Laplace transform of 6 into e raised to minus t. So both sides I took Laplace transform, that is L operator either side. So therefore I written Laplace transform of y double dash plus 4y dash plus 4y equal to Laplace transform of 6 into e raised to minus t. So now see, I split this one. So therefore I will write Laplace transform of y double dash plus, so 4 constant you keep outside and you write Laplace transform of y dash plus you write 4 constant Laplace transform of y, you write Laplace transform of y, you write, see, Laplace transform of y double dash 4 constant you write outside Laplace transform of y dash, next 4 constant outside Laplace transform of y is equal to is equal to S6 constant you take outside. 6 is constant you take outside, and after that you write Laplace transform of e raised to minus t. So these all things you remember. Now for this I will use Laplace transform of derivatives of function. Just to taken there, Laplace transform of derivatives of function. So Laplace transform of y double dash. See, Laplace transform of y double dash is, so I will write here Laplace transform of y double dash. See, s square y bar. See, y double dash it is y double dash. Laplace transform of y double dash, we are using Laplace transform of derivatives of function. So Laplace transform of y double dash is equal to s square y bar minus s y 0 minus I will write y dash 0 minus y dash 0 plus 4 I will write 4 is constant, you write as it is. Laplace transform of y dash, Laplace transform of first order derivative. So Laplace transform of y dash I will write s y bar minus y of 0 y of 0. After that we are having plus 4 you write, plus 4 you write Laplace transform of y. So Laplace transform of y is simply y bar. You already know y bar is equal to Laplace transform of y, right? Or we can write Laplace transform of y is y bar. E is equal to 6 is constant you take outside. Laplace transform of e raised to minus t. So Laplace transform of e raised to minus t means it is Laplace transform of e raised to minus 1t. See, Laplace transform of e raised to minus t. So Laplace transform of e raised to minus t means it is Laplace transform of e raised to minus 1t. And you have already the formula of Laplace transform of e raised to minus at. So Laplace transform of e raised to minus at is what? 1 divided by s plus a. So likewise you are writing here Laplace transform of e raised to minus t. Laplace transform of e raised to minus t is it is 1 divided by s plus 1. So therefore I will write s square y bar as it is minus s you write as it is. We are having the value of y0. We are having the values of initial values, initial conditions. See, the value of y0 is minus 2. You write y0 is minus 2 here. Y0 is minus 2. See, I am substituting these values, these initial conditions in this equation. S square y bar you write as it is minus s you write. Next one we are having y of 0. So y of 0 is minus 2. Y of 0 is minus 2. It is given in the problem. That value is substituted here minus y dash of 0. So y dash of 0 is 8, and in place of this y dash of 0 you write 8 plus you write 4 as it is. 4 as it is you write. Next after that we are having s of y bar. S of y bar also keep as it is. S of y bar as it is minus y of 0. See, the value of y of 0 we are having. So y of 0 is minus 2. Y of 0 is minus 2. And already one minus sign is here. So minus of minus 2 you write. Minus of minus 2 plus you write 4 y bar as it is. 4 y bar as it is equal to, we are having 6 into 1. 6 into 1 is 6 divided by s plus 1 you write. So it is 6 divided by s plus 1. So therefore you go for further simplification. S square y bar you write minus into minus plus it is 2s. See, s square y bar minus into minus plus 2s. Next you write minus 8 plus 4 into s, it is 4s y bar. 4s y bar. Next s minus into minus plus, minus into minus is plus, 2 4s it is 8, and after that you write plus 4 y bar is equal to 6 divided by s plus 1. 6 divided by s plus 1. Now this minus 8 and plus 8 get cancelled. Minus 8 plus 8 get cancelled. So therefore I will write s square y bar. So all the y bar I will write together. S square y bar plus I will write 4s y bar. Say 4s y bar plus I will write 4 y bar and plus 2s is equal to 6 divided by s plus 1. 6 divided by s plus 1. So now therefore in this y bar is common. See, y bar is common in this one. We take it outside. So therefore I will write s square plus 4s plus 4 into y bar. Into y bar. See, in this y bar is common. We take outside. Inside bracket we will get s square plus 4s plus 4 into y bar is equal to 6 divided by s plus 1 you write as it is. 6 divided by s plus 1 you write as it is, and you take plus 2s in this side. You take plus 2s in this side, it becomes minus 2s. So minus 2s by 1 it is. Minus 2s divided by 1. So now see, therefore it is in the form of a square plus 2ab plus b square. See, it is in the form of a square plus 2ab plus b square. So a square is s square plus 2, a is 2, and sorry, a is s, b is 2, and b square means 2 square. So you write this as s square plus 4s plus 4. S square plus 4s plus 4 is s plus 2 whole square. See, s square plus 4s plus 4 is s plus 2 whole square into y bar is equal to, you write 6 divided by s plus 1 minus 2s divided by 1. See, for this I am using a square plus 2ab plus b square is equal to a plus b whole square formula. Here the value of a is s square, b is 2, and this is 2ab, 4s is 2ab. So I applied a square plus 2ab plus b square formula, a square plus 2ab plus b square. So see, s square plus 4s, 4s is 2 into s into 2 plus b square means 2 square. So now see, the value of a is s, b is 2, a square is s square, b square is 2 square. So therefore s square plus 2s into 2 plus 2 square is s plus 2 whole square. Y bar is equal to 6 divided by s plus 1 minus 2s divided by 1. Alright. So next, after this I will take s plus 2 whole square on that side. So I will take s plus 2 whole square on the right side. So s plus 2 whole square is multiplied with y bar. S plus 2 whole square is multiplied with y bar. So I will take s plus 2 whole square in this side. It becomes division. So therefore I will write y bar is equal to, the y bar is equal to 1 divided by s plus 2 whole square. 1 divided by s plus 2 whole square. Inside a bracket I will write 6 divided by s plus 1 minus 2s divided by s1 it is. Alright. So s plus 2 whole square is multiplied with y bar. If you take s plus 2 whole square in this side, it becomes a division. So now therefore I will write y bar is equal to 1 6 the 6. Next you write s plus 1, and after that you write s plus 2 whole square, or you can write this as s plus 2 whole square into s plus 1. Both are same. S plus 2 whole square into s plus 1 is same as s plus 1 into s plus 2 whole square, because multiplication is commutative. Multiplication is commutative. You can write ab is equal to ba. So I will write this as s plus 2 whole square into s plus 1 minus, I will write 2s as it is, and s plus 2 whole square into 1. S plus 2 whole square into 1 is s plus 2 whole square. S plus 2 whole square. Now therefore y bar value I will take. Y bar value is Laplace transform of y. Y bar value is Laplace transform of y is equal to, I will write 6 divided by s plus 2 whole square into s plus 1 minus 2s divided by s plus 2 whole square. S plus 2 whole square. So therefore y equal to, you take L in this side. You take L in this side. It is the inverse Laplace operator. Inverse Laplace operator of 6 divided by s plus 2 whole square. S plus 2 whole square into s plus 1 minus 2s divided by s plus 2 whole square. You call this is equation number, you call this is equation number s1. or you can call this is equation number 2. Already equation number 1 is over. So now see, so both these values are not in standard form. So these two values are not in standard form. So how to write these two values are in standard form. So I lift this one, and for this I will apply a partial fraction method, and I will write 6 divided by s plus 2 whole square into s plus 1 is in standard form. Let us see how to write. So therefore I will write 6 divided by, or yes, you can write 6 divided by s plus 2 whole square into s plus 1 is equal to 6 is a constant, you take outside, and for this I will apply partial fraction method. See, we are having a partial fraction method. 1 divided by x plus a whole square into x plus b is equal to, we are writing a divided by x plus a plus b divided by x plus a whole square plus c divided by x plus b. So that formula we are using here. See, 6 divided by s plus 2 whole square into s plus 1. We are writing this as 6 divided by 6 into a divided by s plus 2, a divided by s plus 2 plus b divided by s plus 2 whole square, b divided by s plus 2 whole square, and after that I will write a plus c divided by s plus 1, c divided by s plus 1. So partial fraction method applied. Partial fraction method. See, once again, when you have a divided by, or when you have 1 divided by x plus a whole square into x plus b, at that time we are writing this as a divided by x plus a plus b divided by x plus a whole square plus c divided by x plus b. So that is partial fraction method. That method I am using here. 6 divided by s plus 2 whole square into s plus 1 can be written as 6 is constant, you take outside, and for these all you apply partial fraction method. So a by s plus 2 plus b divided by s plus 2 whole square plus c divided by s plus 1. So now you cancel 6 and 6. Cancel 6 and 6. So therefore you will get 1 divided by s plus 2 whole square into s plus 1 is equal to a divided by s plus 2 plus b divided by s plus 2 whole square, s plus 2 whole square plus c divided by s plus 1, c divided by s plus 1. So call this is equation number 3. You just call it is equation number 3. So now see, I go for further simplification. I go. See, therefore I will write 1 divided by s plus 2 whole square into s plus 1 is equal to, you find LCM of the denominator. You should find the LCM of s plus 2 whole square into s plus 1. See, here we are having s plus 2, and here denominator is s plus 2 whole square, and here it is s plus 1. So LCM will become s plus 2 whole square into s plus 1. LCM will become s plus 2 whole square into s plus 1. So here you multiply this a by s plus 2 into s plus 1. For this b by s plus 1 and c by s plus 2 whole square, right? So see, therefore I will write a into I will write s plus 2 into s plus 1 plus I will write b into I will write see, already we are having s plus 2 whole square, so b into you write s plus 1, b into s plus 1. Next you write plus c into s plus 2 whole square. See, a into I written s plus 2 into s plus 1. Next b, yes, we are multiplying s plus 1 to this one and as well as this one, and c divided by s plus 2 whole square. Next you write divided by you are having s plus 2 whole square into s plus 1. s plus 2 whole square into s plus 1. This s plus 2 whole square into s plus 1. This s plus 2 whole square into s plus 1 get cancelled. Both are get cancelled. So therefore you will get 1 each equal to a into s plus 2 into s plus 1 plus b into s plus 1 plus c into s plus 2 whole square. See, this is very important. This step is very important. You remember this step. So after this, yes, you call this is equation number 4. First you call this equation number 4. After this, you find the values of constants capital A, capital B and capital C. See, we are having capital A, capital B and capital C are the constants. So now I want to find the value of capital A. So you take the value of S is minus 2. You take the value of S is minus 2. So therefore 1 is equal to, see I am taking S is minus 2 in this one, equation number 4. You take the value of S is minus 2 in equation number 4. So now see, minus 2 plus 2, 0. See I am taking S equal to minus 2, in the 4 I will write. In the 4 we get, that is in equation number 4. So see, S is minus 2 in this one, minus 2 plus 2, 0, 0 into this 0, 0 into A, it is whole term is 0. Next one we are having C into S plus 2, C into S plus 2 whole square. So I am taking S is minus 2 in this one, minus 2 plus 2, yes 0, 0 whole square, 0, 0 into C, it is also 0. So now see, so only we have this term, so B into minus 2 plus 1. So therefore I will write 1 equal to minus 2 plus 1 is minus 1b, or you can write minus 1b is equal to s1. So b equal to, you get minus 1. See the value of b, one constant we got here. Next you take the value of s equal to minus 1. You take the value of s equal to minus 1 in this one. S equal to minus 1 you take. Yes, I will write in 4 we get. That is in equation 4 we get. So now see, therefore you will get 1 is equal to, 1 is equal to, yes you take the value of s equal to minus 1 in this one, minus 1 plus 1, 0, 0 into s plus 2, 0, 0 into A, 0, this whole term will become 0. Next b into s plus 1, so s is minus 1, minus 1 plus 1, 0, 0 into b is 0. Next you take s is minus 1 in this one, s is minus 1 in this one, so minus 1 plus 2, minus 1 plus 2 is plus 1, plus 1 whole square is 1, 1 into c is 1c, so 1c is equal to 1, or we are having c is equal to 1. So now you got a second constant, that is c. Next you go for third constant, you go for the value of a. So now it is very important to find the value of a. See, now while finding the value of a, just see, I will use one method here. I expand these bracket, and the expansion of these two bracket is multiplied with a, and as well as I will expand this also, s plus 2 whole square, and afterwards I will make s square square together, and equating the coefficients on both sides of the s squares, so you will get the value of a. So let's see how. So therefore I will write 1 is equal to, see, s into s square. So I will write a first as it is, s into s is s square, s into 1 is s, plus 2 into s is 2s, plus 2 into 1 is 2, right. After that you write plus b into s plus 1, b into s plus 1 you write, plus you write, plus s c into s plus 2 whole square, c into s plus 2 whole square, s plus 2 whole square is s square plus 4s plus 4. See, I applied a plus b whole square formula for this one, a square plus 2ab plus b square. So s plus 2 whole square is s square plus 4s plus 4. So therefore I will write 1 is equal to a into s square, a square, right. Next s plus 2s, 3s, 3s into a, it is 3as, plus a into 2, 2a, plus b into s, bs, plus b into 1 is b, plus c into s square, cs square, plus c into 4s, it is 4sc, plus c into 4, it is 4c, right? So now therefore 1 is equal to c. I will make a square plus cs square together, because yes, we are having s square is common in this one. S square is common, and you take yes, the value of a square and cs square together. So therefore together, and in this s square is common, so I will write a plus c into s square. Remaining thing you write as it is, 3s you write as it is, 2a as it is, plus bs as it is, plus b also as it is, 4sc as it is, plus 4c. These all are not required, you write as it is. Now, so after writing these all, you make or you equate the coefficients of s square on both sides. So see, we are having only one constant here. We are not having s square term. We are not having s term. When you don't have s square and s terms on the LHS side, you think the coefficient of s square and s is what? 0. Coefficient of s square and s is 0. So therefore this 1 you write it as 0 into s square. 0 into s square you write 0 into s square, and plus you write 0 into s, 0 into s you write, and after that you write plus 1 is equal to these all things you write, right? Now you equate the coefficients, so I will write equating the coefficients of s square on both sides we get, s square on both sides we get, s square on both sides we get. See, you are not having a s square coefficient here, so not s square term, not s square term means its coefficient is 0. So here s square coefficient is a plus c, so therefore I will write 0 equal to a plus c, or you can write a plus c equal to what? 0. So already we have the value of c. We have the value of c. That values are substituted here. That values are substituted. So therefore I will write a plus c. So a plus c means a plus 1 is equal to 0, because already we have c equal to 1. You have the value of c equal to yes 1. C equal to 1 you have. So now therefore I will write yes a plus 1 equal to 0. So therefore a equal to, you will get minus 1. A equal to minus 1 you have, right? So we got 3 constants here. One is a is minus 1, b is yes another constant we are having, b is minus 1, and c is 1. These all values are yes substituted in equation number 2, or you substitute these all values in where this equation number 3. In this equation you substitute. So therefore I will write, I will write equation 3 becomes, substitute all the values of a, b and c in equation 3. So equation 3 becomes, I will write equation 3 becomes, so therefore I will write 1 divided by s plus 2 whole square, s plus 2 whole square into s plus 1 is equal to a, see the value of a is minus 1 by s plus 2, plus b is also minus 1, it is minus 1 divided by s plus 2 whole square, minus 1 divided by s plus 2 whole square, plus c means sc is 1 divided by s plus 1 divided by s plus 1. So these all values are substituted in equation number 2. So equation 2 becomes, now yes equation 2 you take this values in equation 2. So therefore I will write equation 2 becomes, so equation 2 becomes, we are having a equation 2 is inverse Laplace transform of, we are having y is equal to inverse Laplace transform of inverse Laplace transform of, see, pause the video and see back the value of equation 2. See, equation, pause the video and see back the value of equation 2. So, see, we are having equation 2 is 6 divided by, so 6 is constant, 6 is constant. So, you will get it is a minus 1 divided by s plus 2 minus 1 divided by s plus 2 whole square plus 1 divided by s plus 1. See, this is the value of what? 6 divided by s plus 2 whole square into s plus 1. So, that values are substituted here. Minus, after this we are having 2s divided. So, next step, this is we simplify y equal to inverse Laplace transform as it is. So, 6 into minus 1, it is a minus 6 divided by s plus 2. 6 into minus 1, it is a minus 6 divided by s plus 2 whole square. S plus 2 whole square. 6 into 1 is a 6 divided by s plus 1. 6 divided by s plus 1. And after this, there is a small change here. So, I will write it is a minus 2, yes, minus 2, I will write it is a s plus 2 minus 2, yes, bracket complete, divided by, I will write s plus 2 whole square. So, bracket complete. Or you write this as a, you write s here, a round bracket for this. You write a round bracket for this, s plus 2 minus 2. So, now, therefore, I will write y equal to inverse Laplace transform of minus 6 divided by s plus 2 minus 6 divided by s plus 2 whole square plus 6 divided by s plus 1. Now, see, you are having minus 2 inside bracket, you write s plus 2 divided by s plus 2 whole square. Next, s minus into minus plus 4 divided by s plus 2 whole square, bracket complete. See, simplification, minus 2 into s plus 2, minus into minus plus 2 to the 4 divided by s plus 2 whole square. So, now I will write y equal to inverse Laplace transform of minus 6 divided by s plus 2 minus 6 divided by s plus 2 whole square plus 6 divided by s plus 1, 1 s plus 2 and 1 s plus 2 for s plus 2 whole square get cancelled. It is minus 2 divided by s plus 2 plus 4 divided by s plus 2 whole square. Right. So, now see, therefore, y equal to inverse Laplace transform minus 6 divided by s plus 2 minus 2 divided by s plus 2 minus 6 divided by s plus 2 minus 2 divided by s plus 2. It is a minus 8 divided by s plus 2 because both are having the same denominator. You add the numerator. Next, you are having, so this and this is over. Minus 6 plus 4, it is a minus 2 divided by s plus 2 whole square. Both are having the same denominator. Add and subtract the numerator. Next, after that, you write a plus 6 divided by s plus 1. So, therefore, I will write y is equal to, yes, you first write a 6 divided by s plus 1, 6 divided by s plus 1 minus 8 divided by s plus 2. See, 6 divided by s plus 1 you write minus 8 divided by s plus 2 minus 2 divided by s plus 2 whole square you write. So, now see, I will apply universal Laplace operator. Yes, you don't leave universal Laplace operator here. So, therefore, y equal to write a universal Laplace operator. Universal Laplace operator is required. So, now, therefore, I will write y equal to, so y means it is f of t. Y is f of t is equal to inverse Laplace transform of 6 by s plus 1, inverse Laplace transform of 8 by s plus 2, 8 by s plus 2, next minus 2 or inverse Laplace transform of 2 divided by s plus 2 s whole square it is. So now see, 6 is constant, inverse Laplace transform of 1 divided by s plus 1, it is e raised to minus 180, minus 8 is constant, inverse Laplace transform of 1 divided by s plus 2, it is e raised to minus 2t, minus. So this is the very important, two constant you take outside, inverse Laplace transform of 1 divided by s plus 2 whole square. For this you apply shifting property, that is a shifting theorem of the Laplace transform you have to use. So see, we are having a shifting theorem. So Laplace transform, inverse Laplace transform of t into e raised to 80. So t into e raised to 80 is a Laplace transform of t into e raised to 80 is what? It is 1 divided by s minus s plus 2 whole square, s plus a whole square. So minus 2 is constant, inverse Laplace transform of 1 divided by s plus 2 whole square is t into e raised to minus 2t, 2 into t into e raised to minus 2t. So this is the value of y, this is the required value of y, and this is the method to find or to solve ordinary differential equations of second order and third order. So kindly share it and subscribe my channel. Thank you for watching.